Hello, today we will read about AZ204 Implement Azure App Services Web Apps. In this lesson, we will learn how Azure Web App functions and how to create and update an app. Explore app service, authentication and authorization, configuring app setting, apps, scale apps, and how to use deployment slot. So we will start with the first chapter, that is exploring Azure App Services. Introduction. Your company is considering moving their web app to cloud and has asked you to evaluate Azure App Service learning objectives. After completing this module, you will be able to describe Azure App Service key components and value, explain how Azure App Service manages authentication and authorization, identify methods to control inbound and outbound traffic to your web app, deploy a app to app service using Azure CLI command. Unit 2. Examine Azure App Service. Azure App Service is an HTTP-based service for hosting web application, REST API, and mobile backend. You can deploy in your favorite programming language or framework. Applications run and scale with ease on both Windows and Linux-based environments. So this section tells us that Azure App Service is an HTTP-based service for hosting web apps, web applications, REST APIs that are web APIs, and mobile backend. I think nothing but web APIs again. You can deploy in your favorite okay, you can develop, not deploy, develop in your favorite programming language or frameworks. Applications run and scale with ease on both Windows and Linux-based environment. Okay, so Azure App Service supports both environments, that is Windows and Linux, for running the applications, and it also allows scaling on those applications. Okay, let's proceed. Built-in auto scale support. The ability to scale up/down or scale out/in is baked into Azure App Service. Depending on the usage of the web app, you can scale the resource of the underlying machine that is hosting your web app up or down. Resource includes the number of cores or the amount of RAM available. Scaling out/in is the ability to increase or decrease the number of machine instances that are running the web app. Okay, so built-in auto scale support. So it is the ability to scale up or down or scale out or in. Up or down would scale the CPU and would scale the CPU, that is nothing but the cores, and the amount of RAM. And scaling out is the ability to increase the number of instances that is running on the web app. Container support. With Azure App Service, we can deploy and run containerized web app on Windows and Linux. You can pull container images from private Azure Container Registry or Docker Hub. Azure App Service also supports multiple container apps, Windows containers, and Docker Compose for orchestrating container instances. Okay, This means that as your app service supports running containers, and the container images can be from the private Azure container registry or the Docker Hub. It also supports multiple container apps, Windows containers, and Docker Compose for orchestration. So it has container support. Okay, next feature, continuous integration slash deployment support. The Azure portal provides out of the box continuous integration and deployment with Azure DevOps services, GitHub, Bitbucket, FTP, or a local Git repository on your development system machine. Connect your web app with any of the above resources, and app service will do the rest for you by auto syncing code and any future changes in code into the web app. Continuous integration and deployment of containerized web app is also supported by using Docker Container Registry or Docker Hub. So what is continuous integration and deployment support? So out of the box, web app supports deployment with Azure DevOps services, GitHub, Bitbucket, FTP, and local Git repository. Connect your web app with any of the above, and app service will do the rest to auto sync your code and any feature changes to the code into the web app. Continuous integration and deployment of containerized web app is also supported using either Azure Container Registry or Docker Hub. Okay. Deployment slots. When you deploy your web app, you can use a separate deployment slot instead of the default production slot when you're running in the standard app service tier or better. Deployment slots are live apps with their own host names. App content and configuration elements can be swapped between two deployment slots, including the production slot. App content and configuration elements can be swapped between the two deployment slot using the including the production slot. Okay, so till now, what are the features that we have read? We have read built-in auto scale out support, that is the ability to scale up or down, out or in. Containerized support, that is the ability to basically deploy your container image to the web app. Continuous integration and deployment with the help of Azure DevOps, Bitbucket, GitHub, FTP, or local code changes can be deployed into the web app. Also, continuous and deployment for container web app is also supported using Azure Container Registry. Deployment slots. You can deploy web app onto a separate deployment slot instead of the production slot. When you run basically in standard plan or above that, deployment slots are live apps with their own host name and swap between the this and the production slot. Okay. App services on Linux. App services can also build web app natively on Linux for supported application stack. It can also run custom Linux container. App service on Linux supports many languages, specific built-in containers. Just deploy your code. Supported language and frameworks include Node.js, Java, PHP, Python, .NET, Ruby. If the runtime your application require isn't supported in the built-in image, you can deploy it with your custom container. The language and your supported versions are updated regularly. You can retrieve the current list using the following command in Cloud Shell. Okay, would like to test this command out. So basically, app services on Linux. App service can also host web application natively on Linux for supported application stacks. So can also host web services natively on Linux. Okay, it can also run custom Linux containers, also known as web app of for containers. Okay, app services app service of Linux supports many languages specifically built in image many language specific built-in image. Just deploy your code. Supported language and frameworks include Node.js, Java, PHP, Python, Ruby, and .NET. If the runtime your application require isn't supported in the built-in image, you can deploy it with a custom container. Okay, let's check the list of web app containers available. So what we can do is run this command and check whether the web app can run AC login login 3 AZ web app list runtime runtime. Okay, so for Linux .NET 9.8.7.6 Node in 18.6 Python, PHP, Java, for Windows .NET 8.6 ASP.NET, Node, Java, and .NET, .NET Core. Interesting. Easy web app list runtimes OS type Linux. OS type Linux. Okay. Okay. Limitations. App service of Linux does have some limitations. App service of Linux isn't supported on shared pricing tier. Okay. The Azure portal shows only features that currently work for Linux app. As features are enabled, they activate on the portal. Shows Azure app Azure portal shows only features that currently work for Linux app. As features are enabled, they activate on the portal. When deployed to built-in images, your code and content are allocated. uh, When deployed to built-in images, okay, your code and content are allocated a storage volume for web content backed by Azure storage. The disk latency of this volume is higher and more variable than the latency of the container file system. Apps that require heavy read-write access to the content file may benefit from a custom container option, which place files in the container file system instead of the content volume. When deployed to built-in image, your code and content are allocated on the storage volume of the web content backed by Azure storage. The latency of this volume is higher and more variable than the latency of the container app service. Apps that require heavy read-write access to the content file may benefit from the custom container options which placed in the container file system instead of content volume. Okay, so recapping the limitations, Linux app services are not supported by the shared pricing tier. The features on Linux, only features that are currently working in shows only features that are currently working. As new features get activated, they show up automatically. So some features on Linux app services um, are not seen in the portal, which are seen for the Windows app services. Deployment with the built-in image of the code and content are allocated on storage volumes that is backed by Azure storage. The disk latency of this volume is higher and may vary than the latency of the container file system. The app requires heavy read-write content may benefit from a custom container option which places the files in the container file system instead of the content volume. Okay, so basically move use a custom image so that the stay with the files of the container file system rather than the content volume, that is the storage account volumes, because the latency of the volume is higher. Okay, understood. Let's proceed to the next unit, that is examining Azure App Service plans. So examine Azure App Service plans. In app service, an app always runs in the app service plan. An app service plan defines a set of compute resources for a web app to run. One or more apps can be configured to run on the same computing resources or the same app service plan. Okay, so an app service requires a app service plan to run. The app service plan defines a set of compute resources for the app to run. One or more apps can be configured to run on the same compute resources. In this case, the compute resource is same as the app service plan. When you create an app service plan in a certain region, for example, West Europe, a set of compute resources is created for the plan in that region. Whatever apps you put in the app service plan run on these compute resources as defined by your app service plan. Each app service plan defines, okay, operating system. So app service plan can define the operating system, the region, the number of VM instances, size of the VM instances, and pricing tier. Recapping what each app service plan defines. It's the operating system, the region, the number of VMs, the size of VM, and the pricing tier. Operating system can be Windows or Linux. Regions can be any region where the Azure data center is located. Could be East US, West US, East Europe, West Europe. Number of VM instances. Okay. Size of VM instances, small, medium, large. Pricing tier, free, shared, basic, standard, premium, premium V2, premium V3, isolated and isolated 2. The pricing tier of a web app plan determines what app service features you can get and how much you have to pay for the plan. The pricing tier, okay, of the web app plan determines what app service feature you get and how much, okay, app service features you get and how much you have to pay for a plan. There are few categories for pricing tiers. Shared compute, free and shared. The two basic tier runs an app on the same app service, free and shared. The two basic tiers run a app on the same Azure VM as other app service as other app service apps, including apps of other customers. These tiers allocate CPU quota to each app that runs on a shared resource and the resource cannot scale out. Okay, shared compute. So the free and the shared pricing tier, basically these two pricing tiers will place the app on the same Azure VM as other apps, so it's not dedicated. There are other app services also on that VM. Not only our apps, but apps of other consumers also. So other customers also might put their apps in the same pricing tier, they will all be allocated the same shared resources. Dedicated compute, the basic, standard, premium V2 tiers run app on dedicated Azure VMs. Only app in the same app service share the same compute resources. The higher the tier, the more VM instances are available for you to scale out. Isolated, the isolated one run dedicated VMs on dedicated Azure virtual network. It provides network isolation on top of compute isolations. It provides a large number of scale out capabilities. Okay, so we have shared compute, we have dedicated compute, and we have isolated compute. Shared compute, basically the resources that your app services, the VM behind is shared between multiple app services uh, belonging to different users also. Dedicated, it is only a dedicated VM and only apps in the same app service plan will use the VM. The other outside consumers don't get access to it. Isolated has an isolated virtual network on top of the isolated compute that is already there in the form of the VM. So along with the compute of the VM, the network also is isolated in this case, and it provides the max scale out capabilities. Note, app service free and shared hosting plans have basic tier that runs on the same Azure virtual machine as other app service plans. Some app might belong to other. These tiers are intended to be used only for deployment and testing. Okay. How does my app runs and scale? Mhm. In the free and shared tier, an app receives CPU time on a shared VM instance and cannot scale out. In other tiers, an app runs as follows. We know that the app receives time on the shared VM, right? So basically, the VM that is shared, it receives CPU time on the shared VM. In other, app runs and scales as follows. An app runs on all the VM instances configured in the app service plan. Okay, an app runs on all the VM instances that are configured in the app service plan. If multiple apps are in the same app service plan, then all share the same VM instances. If you have multiple deployment slots for an app, all deployment slot also run on the same VM instances. If you enable diagnostic logging, perform backups, and run web jobs, they also use CPU cycles and memory of this virtual instance VM instances. So that's diagnostic logs, perform backups, they also use the same. So basically, the web app runs on all VM instances that are part of it. If there are multiple apps in the same, then they all share the same VM. If you have multiple deployment slots, the all deployment slots run on the same VM instances. If you enable diagnostic logs, perform backup, they also run. In a way, the app service plan is the scale unit of the app service apps. If the plan is configured to run 5 VM instances, then all apps in the plan run on all 5 instances. If the plan is configured to auto scale, then all apps in the plan are scaled out together based on the auto scale out settings. In a way, the app service plan is the scale unit of the app service app. If the plan is configured to run 5 VM instances, then all app in the app run on the 5 instances. If the plan is configured to auto scale out, then all apps in the plan are configured together based on the auto scale out plan. What if my app needs more capability or features? Your app service plan can be scaled up and down at any time. It's it's as simple as changing the pricing tier of the plan. If your app is in the same app service plan with other apps, you may want to improve the app's performance by isolating the compute resources. You can do it by moving the app in a separate app service plan. Y- You can potentially save money by putting multiple apps into one app service plan. However, since apps in the same app service plan all share the same compute resource, you need to understand the capability of the existing app service plan and expect the load for the new app. Isolate your app into a new app service plan when the app is resource intensive. You want to scale the app independently from the other apps in the existing plan. The app needs resource in a different geographical region. the way you can allocate a new set of resource for your app and gain greater control of your app. Okay, what does this mean? What if my app needs more capability or features? Okay, the app service plan can be scaled up or down. It's simple as changing the pricing tier of the plan. If your app is the same app service plan with other plans, you might want to improve the app performance by isolating the compute resources. You can put it by moving the app in a separate app service plan. Basically, you can scale up and down at any time. It's as simple as changing the pricing tier, right, on the app service plan. But your app is in the same with the others. You may want to improve the app's performance by isolating it, moving it separately to a different app service plan. You can potentially save money by putting multiple apps in the same. However, since apps in the same use the shared compute resources, you must understand the capabilities uh, of the existing app service plan and the expected load of the new app. So isolate your app into a new app service plan. If the app is very resource intensive, it wants more resources to execute. You want to scale the app individually from the other apps. So that in that case, you need resources in different regions. So yeah, okay. Let's move on to the next unit. That is deployment of app services. Okay. Deployment deploy to app services. Every deployment, every development team has unique requirements that can make implementing an efficient deployment pipeline difficult on any cloud service. App service supports both automatic and manual deployment. Every development team has unique requirements that can make implementation efficient of a efficient deployment pipeline difficult for any cloud service. App service supports both automated and manual deployment. Okay, not understanding every development team has unique requirements that can make implementing a efficient deployment pipeline difficult on any cloud service. Okay. Automated deployments or continuous deployments is a process used to push out new features and bugs fixes in a fast and repetitive pattern with minimal effort on end user. Automated deployment or continuous deployment is a process used to push out new features and bug fixes in a fast and repetitive pattern with minimal effort on end user. Azure supports automated deployment directly from several resources. The following options are available. Azure DevOps services. You can push your code to Azure DevOps, build your code in cloud, run the test and generate a release from the code, and finally push the code to Azure App Service. GitHub. Azure supports automated deployments directly from GitHub. When you connect your Git repository to Azure for automated deployments, any changes you push to the production branch on GitHub can automatically deployed for you. Bitbucket. With its with its similarities to GitHub, you can configure a automated deployment with Bitbucket. Okay, automated deployments basically Azure DevOps, GitHub, Bitbucket. Basically, you push your code and the code automatically builds and then is pushed to the web app automatically. Hmm. Manual deployment. There are few options that you can use to manually push your code to Azure. Git apps apps service web app features a Git URL that you can add as a remote repository. Pushing to the remote repository deploys your app. Git app service web app features a Git URL that you can add as a remote repository. Pushing to the remote deploys your app. Features a Git URL that you can add a remote pushing CLI. Web app up is a feature of the AZ command line interface that package your app and deploys it. Unlike other deployment methods, AZ creates a new app service for you if you don't already created one. Zip deploy. Use curl or a similar HTTP utility to send a zip of your application to app service. FTP. FTP or FTPS is a traditional way to pushing your code to many, including app service. Manual deployment. So in Git, there is the remote URL which you can add in the apps service because it has a feature, and then pushing to the remote can push. Okay, but then there is CLI, and there is CLI is basically AZ web up that basically pushes your code to the web app and also creates a web app if it is not there. Zip deploy basically uses curl or similar HTTP utility to send a zip of your this HTTP and HTTPS. Using deployment slots. Whenever possible, use deployment slots when deploying a new production build. When using a standard app service pricing tier or better, you can deploy your app to and then swap your stage and prod slots. The swap operation warms up the necessary worker instance to match your production scale, thus eliminating downtime. Whenever possible, use deployment slots when deploying a new production build. When using a standard app service, or better, you can deploy your app to a staging environment and then swap your staging and production from the swap means warms up the necessary worker instances to match your and thus eliminates downtime. Okay. Continuous code deploy continuously deploy code. If your project has designed designated branches for testing, QA, and staging, then each of those branches should be continuously deployed to a staging slot. This allows your stakeholders to easily access and test the deployed branch. But staging, huh? Continuous deploy, continuously deploy code. If your project has designated branches for testing, QA, and staging, then each of these branches should be continuously deployed to a staging slot, which allows your stakeholders to easily access and test the deployed branch. Continuously deploy containers. For custom containers from Azure Container Registry or other container registries, deploy the image into a staging slot and swap it with production to prevent downtime. This automation is the automation is more complicated than code deployment because you must push the image to container registry and update the image tag on the web app. For custom containers from Azure Container Registry or other container registries, deploy the image into a stage slot and then swap it to prevent downtime. The automation is more complicated than code deployment because you must push the image to the automation is more complicated than code deployment because you must push the image to the container registry and update the image tag on the web app. Build and tag the image. As part of build pipeline, tag the image with the Git commit ID, timestamp, or other identification information. It's best not to use the tag latest default latest tag, otherwise it's difficult to backtrack the code is currently deployed, which makes debugging more difficult. Push the tagged image. Once the image is built and tagged, the pipeline pushes the image to our container registry. In the next step, the deployment slot will pull the tagged image from the container registry. Update the deployment slot with the new image tag. When this property is updated, the site will automatically restart and pull the new container image. So basically, we can just code deploy, but we can also continuously deploy container images. Basically, bundle your code in the container and update it in the Azure container registry. Once you update it in the container registry, you update the tag in the app service, and that is it. It will then work with the latest. Interesting. So deployment, automated Azure DevOps, GitHub, Bitbucket, manual, Git, CLI, zip deploy, using slots, continuous code, and with containers. Next unit, explore authentication and authorization in app service. Explore authentication and authorization in app service. Azure App Service. Pause, man.